Hello everyone. In our session today, we want to look at finding out the address of each subnet and finding the address of each node within the subnet. Previously, we looked at dividing a network address up into subnets. Now what we want to do is to find out the address of each of those subnets. And when we have found that out, we then want to find out the address of each node within that subnet. We're going to be working with a Class C network address for our example. The subnet mask of that Class C network address is 255.255.255.224. The question is, we have figured out how many subnets we can divide a network into. We are now going to see how we're going to find out the address of those subnets. The first thing you want to do is to look for the quad in the subnet mask that has the combination of zeros and ones. And from our previous lessons, we learned that we can convert a binary number into decimal and decimal into binary. And here we have our subnet mask, which is 224, and the binary equivalent of that is 111.00000. So this section here, the last quad, is the section that has the combination of the zeros and the ones. So it is that decimal value that we want to use to find out the address of the subnets. What we do after we have found out that decimal value is to subtract the decimal value from the number 256. 256 numbers total comprising the range 0 to 255. In other words, there are 256 numbers total, 0 to 255 including the 0. Now what you do is to take that quad, the decimal value of that quad, and you subtract it from 256. In our example, we have 224. So if we say 256 minus 224, we're going to get 32. And 32 is the number that we're going to use to decide the addresses of our subnets. Let's look and see. Using the 32 we got when we subtracted 224 from 256, we can now determine the address of the first network. So our network address for the first subnet or network is 192.168.732. Remember how we got the 32? We subtracted 224 from 256. So to calculate the network addresses of the other subnets, all we do is increment the results of our previous subtraction by itself. So if the first address ended with 32, then the second one would be 64. That's 32 plus 32. Then you're going to take 64 and you're going to add 32 to it, and that will be 96. And that will be the address of the next subnet. We do the same for the one that follows. If you add 32 to 196, you get 128. If you add 32 to 128, you get 160. And if you add 32 to 160, you get 192. And that is how we calculate the address of each subnet. So you first have to know the subnet mask. Find that quad that has the combination, and you use that figure and you subtract that from 256, gives you your first, you double, and then you keep adding the increment repeatedly. Now, how do we go about calculating the IP address in each subnet? For example, our first subnet is 192.168.732. How do I know the addresses of the nodes within that subnet? Well, you start with the first one, because if your address is 32, then the first node or the first computer will be number 33. So your first computer node would be 192.168.733. Your second one will be 34, 35, and so on. And you go right down to 62. So you have the beginning address at 192.168.733 and the ending address at 192.168.762. And you might be wondering, well, where is 63? Well, we have to omit 63. We cannot put it as a part of the network address, because if we do that, the address would have a binary host identifier value of 11111, which is a broadcast address, and we can't use that address. So watch out for that in an exam where you would be asked if a particular IP address is an address for a node in the network. You can't use the broadcast address. Now, if your last node is 62, then 63 is a broadcast address, and then the next network node is 64. So the next subnet, that address is 64. So the addresses in that would start from 65 and go to 94. And then you would go then from 97 to 126. Then 129 to 158. Then 161 to 190, and so on. So remember, we leave out the address just before the next network address, which we refer to as the broadcast address. Don't put that as an address for a node in your network. This is how we calculate the IP addresses. If you are asked in an exam to give the first address of a subnet and the last address, then you'll be able to calculate it based on the method that we looked at in this session. In a previous session, I had promised to give you the table of high bit sums that you would use for calculating your subnet mask. And you can memorize this table. If you can memorize the table, then you wouldn't have to calculate the subnet mask number. For example, we know that 192 is a 2-bit number. So if you see 2 bits within the octet, you know that's 192 decimal. If you see 1 bit, you know it's 128. If you see 3 bits, you know it's 224. What we would have done is we would have put the bits out, and then we double the numbers going from right to left, and then counted the value of the ones. So you can use that method to calculate it. But if you can remember that table, you would know that when you see a quad and the quad has 2 bits, 2 1 bits that is, and 6 zeros, it's a 192. If you see 3 1 bits, it's a 224. If you see 4 1 bits, it's 240. So if you can memorize that, it'd be easier to work out your subnet mask. instead of doing the calculation. This table is available to you in your required reading. We're going to be doing some of these examples for your hands-on. I'm going to give you a number of them so you can practice them. So look in the hands-on lab section for some questions on subnetting that you can practice on your own. This is the end of our session, and I want to thank you for listening.